Today we're looking at minimum spanning trees. So firstly, what's a minimum spanning tree? Well, the best bit to start off is what is a tree? So a tree, let's say we have a network like this. Alright, now a tree is something like this. You just connect that thing up and there's no cycles and it's a subgraph. So a cycle looks like this. So now I've added an extra edge to this graph. And we can see it's a cycle because I could start here, go up, down and back and sort of keep doing that in a cycle. So hopefully that loads up soon. So, nope, not loading. Okay, well I've drawn arrows, there we go. I've drawn arrows there saying that it's going to keep cycling like that. So that's a cycle. You can't have that in a minimum spanning tree or a tree. So what we're trying to do is make sure that everything looks like this. Alright, now a spanning tree is where you cover all the nodes with edges like that, and there's no cycles. And a minimum spanning tree, and that's what we're focusing on today, is to make this spanning tree using the shortest amount of resources possible. The process we use for this is called Prim's algorithm, and the steps are shown just here. Okay. Now we're going to follow those steps to help us find the minimum spanning tree for the graphs below. Okay. And we're going to have a crack at that now. So step one. Step one says choose any vertex within the network. Well, I'm going to, and I'm scrolling down here, I'm going to start off with A, just there. Now, it doesn't really matter where you start, but I like starting with A. Now, the next step, step 2, says find the edge with the lowest value connecting this vertex to any other vertex. So we have an 11 and a 12. We're trying to find the minimum spanning tree, so we're going to choose the 11. So that means we're connecting up the edge between the vertices A and B. There we go. We do the same process again. Okay, so step 3 says look at all the edges connecting these two vertices and choose the edge that has the lowest value. So I can look from A. So if I look from A, what values do I have? 12, and that's it. From B, I've got 7 and 22. What's the lowest one? 7, so I'm going to choose 7. I'm going to highlight this like that, and then rub out what I've done. So I've got that value there now. We do the same process again. It says here, look at all the vertices covered so far and select the edge with the lowest value. So I do that again. Now you may note I've got the 12 there, 22, 16 and 21. Now look at the 12. There's no point using that anymore. If I add an edge, and I'll show you what I mean. If I add an edge, I've made a cycle, so I don't want to do that. What I do want to do is choose the minimum value that will make a minimum spanning tree. In this case, it will be 16. So I draw that across there. I'm going to choose that C to D edge now, and then I'll rub out the rest like that. All right, we'll do the same thing again. We're looking from that node. We have an 8, 22, 21, and a 7. And I'm going to just cross off that edge so I don't keep looking at it. Okay, so which one's the lowest? The 7. So we highlight that path. I've chosen, yep, there we go. And I'm going to rub out the rest. We do the same process again, looking from every edge. Okay, and now we can cross off that 21. That's useless now. And now, in this case here, you may note that we've got two 8s, ED and FG. So which one do we choose? The answer is it doesn't matter. So which one do you choose? It's up to you. It's just random. You will get sometimes a slightly different answer, but they will both be correct. So there might be different ways you could do the same thing. So I've chosen E to D. I'm going to highlight that edge there. And I've noticed I've got another edge there that's useless, so I've crossed that out. Our next step is to do that all over again. Circle, 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 and highlight the path as the lowest. Got that one there. Rub out the rest. Okay, and what do we have left? 7 there, so I'm just going to highlight that. And what we have left now, 9, 10, 10, 9, well, I'll choose the 9, it's the lowest. And you may note I've covered all the vertices now. So, there we are. We've shown the minimum spanning tree and that'd be worth, I'd say, around 3 marks in a test. What we're going to do now is just add up the minimum value. So this might be, thousands of dollars required to build a road or something like that. So we add up those weights, 11 plus 7 plus 16 plus 7 plus 8 plus 8 plus 9 plus 7. And a little bit of calculator work here for you. The answer I've got here is 73. And in this case, let's just say units. We want to add our units. There we go, that's that first example for the minimum spanning tree.